Welcome, and in this video you're going to get an explanation of how the light detection circuit I used in Project Slade works. And if you haven't checked out that video yet, you can click up here, or let's get right into this explanation. So, the inspiration for my circuit I acquired from a potentiometer circuit I saw online after watching a YouTube video of an old guy explaining how you can use the analog to digital converter pin on the Raspberry Pico Pi. But the principle from that circuit was the following. You have a potentiometer, okay? This is the other person's circuit that I saw, and that inspired me to make mine, okay? You have a potentiometer, and for those who might not know, on the potentiometer you have 3 pins. One's the high voltage, the other one is where you put the ground voltage, and then the middle one is where you have the variable voltage output. As you spin the pin on the potentiometer, that'll change the resistance, which therefore changes the output voltage right here at this middle node. So essentially, what the old guy did on YouTube is he took this middle voltage here, right, the variable output voltage, and connected it to the analog to digital converter on the Raspberry Pico Pi. And then what the Raspberry Pico Pi does is it takes the voltage in and it converts the analog signal into a digital signal, which then allowed to quantify the resistance of the potentiometer. Now, I applied the similar principle. I'm not sure if this is the most effective way, possibly more effective ways, but it did the job, and that's what I needed. So, essentially, right, for my circuit, I have the high voltage right here, okay? And then I have my photoresistor here, okay? And then I have an arbitrary resistor right here connected to the ground. So essentially, I have photoresistor and a normal resistor connected in series. And the normal resistor which I used was a 1K resistor, so 1000 ohms, but it doesn't really matter. Essentially, what we want is we just want a ratio of voltage drops to be created here. As the resistance value changes in the photoresistor, we're going to have a ratio of voltage drops. And that will therefore change the value, the voltage value of this node. So, for example, let's say the resistance value of the photoresistor is 1K, okay? 1000 ohms, and here it's also 1000 ohms. That means that if this is a voltage of 3, we're going to have a voltage of 1.5 here because 50% of the voltage is dropped here, and another 50% of the voltage is dropped here. Now, similarly, if you think, let's say the voltage of the photoresistor is now 2000 because we changed the lighting in the room, okay? Now, we're going to have 2/3 of the voltage drop here and 1/3 of the voltage drop here. So now the node, as opposed to being a voltage of 1.5 here, it's now a voltage of 1, okay? Finally, I connected this node here to the analog to digital converter of the Raspberry Pi. And then I was able to measure and acquire a digital value which represents the resistance of the photoresistor. And therefore, I can now quantify and measure the lighting and the light intensity in the room and determine when I want my device to turn on or off.